In this short video, I'm going to be going over the row operations in a bit more detail. So the first row operation we talked about was to swap rows. And we have here an example where we may think about swapping rows. We have a 2 in position 1, 1, and then there's a 1 in the second row in position 2, 1. So instead of dividing across this one by 2, we can just swap those two rows, and that gives us a 1 in that position there. So that's our pivot, and it'll be easier to then get zeros underneath. So the new matrix will look something like this with a 1 in there. Another situation where you may think about swapping rows is if you have zeros somewhere in this area up here, you can swap to have them down in this area. So we move on, and the second row operation that we can perform on a matrix is to multiply a row by a number, and it's always multiply or divide because we can always multiply by a fraction. So an example of this operation would be if we have a matrix like this one here. We want to continue getting a 0 down here, and the easiest way to do that is to get a 1 here first, and then say minus 7 times row 2 plus row 3 is the new row 3. But for that to work, we need to have a 1 in this position. So what we're going to do is multiply the entire row 2, multiply it by 1 over the value that is there instead of the 1, in this case the minus 2. So the value we want to make disappear. So we multiply by 1 over minus 2 or divide by minus 2, and that will get us this matrix where each number in the second row is equivalent to the one in the second row up here divided by minus 2. And the third row operation is to add a multiple of a row to another row. So we're going to be using that one to get our zeros in the positions where we need them. In this case, I'm using a 2 by 2, a system of 2 simultaneous equations, and we have a 3 here in this position. This has to become a 0. So to get a 0 in that position, we take the number we want to cancel, the 3, take it out, change the sign. In this case, because it's positive, it becomes negative. We multiply it times the pivot in that column, which is the one up here. So minus 3 times the row that contains that 1 is row 1, and then we add that to row 2. And that's going to give us our new row 2, and the calculations are going to be minus 3 from the constant times 1 plus 3, that's our 0 that we were looking for. Always check that it actually gives you 0. Then we're going to have minus 3 times 2 plus 1, we'll write it like that, that's going to be minus 5. Then minus 3 times 3 and plus 1, that's going to be our minus 8, and we replace these values in the new second row. So the new matrix is going to have 0, minus 5 and 8 in the second row, and we'll repeat 1, 2 and 3. So the easiest way, not the only one, but the easiest way to get our zeros when you were doing Gaussian elimination is to get a 1 in the pivot position, then all the zeros underneath, then the next one, all the zeros, and so on. And those pivot positions are what's going to be along the diagonal. So they're going to be this value here, this value here, and we have to continue this value here. For our Gaussian elimination, we're only going to be using this value to get zeros in these two positions, and this value to get the 0 in here. So when we're calculating zeros here, it's always going to say something like minus 2 times row 1 plus row 2, or minus 3 times row 1 plus row 3. Then when it's this one here, to avoid destroying previous work that we've done already, where it's always going to say something like minus 2 row 2 plus row 3. And you can now move on to the examples.